Today I want to explain density. So I have the equation for density written at the top, and density equals mass over volume. So it's a ratio of how much mass something has to its volume. The most common units for density is grams per milliliter. You might also see grams per cubic centimeter because milliliters and cubic centimeters are the same thing. Now, that's mostly for solids and liquids. So those units deal with solids and liquids. You could also see grams per liter, but that's going to be most commonly used for gases. Since gases have such a low density, it would be a decimal if we were using grams per milliliter. So by putting it in grams per liter, it just makes it a better number for us to work with. Now, I want you to look at the two spheres at the bottom of the page. So let's say each one of those spheres has a volume of 1 milliliter. Now, I'm going to use colored spheres to represent how much mass is in that 1 milliliter of space. So let's look at the one on the left first. And let's say I have that much mass in that space. The atoms or molecules, either in that 1 milliliter of volume, have a lot of space between them. So this is a very low density object. There's not a lot of mass in a certain amount of volume. So now let's compare it with something over here. And let's make those spheres green. And I have more of them. And they're more tightly compacted. So since there are more spheres, there's more mass in this volume, and the atoms are more tightly compacted, this has a higher density than this. So how I think of density is that it's the amount of mass contained in a certain amount of volume. The more mass, the tighter those particles are together, the more dense the substance is, versus where you don't have as much mass and the particles are more spaced out, it would be lower density here. So when you think of throwing a rock in a pond, the pond's particles are more spread out, the rock's particles are more compacted, and whatever's a higher density is going to sink. All right, so let's take what we just learned and solve a sample problem. So I have a very particular way I like to solve out word problems. So I like looking at the word problem, and as I read it, I'm going to define my variables. So what is the density of a sample of aluminum metal that has a mass, so mass is M, of 8.4 grams, and a volume, which is V, of 3.1 cubic centimeters. And I'm looking for density, so D equals question mark. Now, if we had more than one equation for this unit, this step would be really important because I can look at these variables and I can say what equation corresponds with one that has density, volume, and mass in it. So later in the year, you're going to have more than one equation to deal with. So this is going to help us pick the equation. So for this problem, it's really easy. I know I'm using density equals mass over volume. Now, the other reason why I like this step is I want to make sure my units are okay. So I have grams and I have cubic centimeters. That is okay. I'm allowed to have grams and I'm allowed to have cubic centimeters according to the previous slide. So now I can just plug my numbers into the formula. So density equals 8.4 grams divided by 3.1 cubic centimeters. And my calculator comes out with a big long answer when I plug that in. So I can also use this for significant figures. So this number has 2, this number has 2. So I'm going to go by the lowest, so I'm only allowed 2 significant figures in my number, and that's why my density comes out to 2.7 grams per cubic centimeter. All right, so try these two on your own, pause the video, and when you get back, I'll show you how to solve these out. Okay, so let's solve out the first one. So the first one is if a piece of stone has a volume, so V equals 310 cubic centimeters, and a mass of 853 grams, what is the density? So density equals question mark. So I know my equation is D equals M over V, and I'm going to plug those numbers in because my units are okay already. So that would equal 853 grams divided by 310 cubic centimeters. That equals, and again, my calculator comes up with a big number. I'm going to use this step over here for sig figs. This number has 3 because of the decimal point, which I forgot to write. Sorry. That number has 3. This number has 3, so I should have 3 in my answer. So that's where that 2.75 grams per cubic centimeter comes from. So let's look at number 2. So I'm going to follow the same process. A sample of mercury has a mass of 76.2 grams. If the density of mercury, so I'm given the density this time, 13.6 grams per milliliter, what is the volume of the sample? So now I'm just solving for something else. I'm still using D equals M over V. My units are okay because mass is in grams and density is in grams. So now I can plug my numbers in. So I get 13.6 grams per milliliter equals mass, which is 76.2 grams, divided by volume. Now, here's where a lot of people will mess up. My variable is in the denominator. So whenever you see a variable in the denominator, the first thing you want to do is get it to the numerator. So I'm going to put this side over 1 and cross multiply. It's just the easiest way I've found to solve these out. So I would have 13.6 grams per milliliter times volume, since I'm cross multiplying, equals 76.2 grams. And now I'm going to divide both sides by 13.6 milliliters, so it cancels. Oh, 13.6 grams per milliliter, sorry. And now my grams cancel. I'm left in milliliters, which is what I want. So volume equals 76.2 divided by 13.6. Both of those numbers have 3 sig figs, so that's where the 5.60 milliliters comes from. Okay, so now this problem is a little bit harder, so I'm going to challenge you to pause the video and give this one a try. I'm giving you a hint that there's a trick, so give it a shot, and when you get back, I will go through how to solve it. Okay, so let's go through this one and make sure we're all right. So if you have 2.3 kilograms, so that is a mass, 2.3 kilograms, of a substance with a density of 11.23 grams per milliliter, what is the volume of this substance? So now I'm going to pick my equation, so D equals M over V, and before I plug in, I want to check my units. I have a problem. Kilograms and grams. So I have to change one of those units before I move on. So I'm going to change kilograms to grams, and I know that in 1 kilogram there's 1,000 grams. So now kilograms cancel, and I'm going to multiply. So that comes out to 2,300 grams. So I'm going to use that number in my calculations. So now let's plug our numbers in. So I have 11.23 grams per milliliter equals mass, which is 2,300 grams, divided by volume. And I need to get my variable off the denominator, so I'm going to multiply both sides by volume, so it cancels on that side. So now I have V times 11.23 grams per milliliter equals 2,300. and I'll divide both sides by 11.23 grams per milliliter. So it cancels there, and then I do the same thing on this side. Grams cancel, I'm left in milliliters, so I'm going to get the right answer. So volume equals, and I just put that in my calculator, 2,300 divided by 11.23, and I'm only allowed two significant figures, because if you look at this number here, it only has 2, and this has 4, so I have to have 2. And this one I have to put in scientific notation because my answer is 204.8085, etc. And the 2 and the 0 are significant, but the 4 doesn't round up the 0. So my answer would be 2.0 times 10 to the second milliliters. All right, so there is a worksheet that corresponds with this going through some of these more difficult ones. Give that a try. If you have any other questions regarding density, just make sure you see me in class tomorrow.